Okay, so here are the problems I did for the take-home portion of the final. I did first the 5 questions I chose from the manipulative section. I started with 5 minus -2 and 5 plus -3, showing it both using the counters and the number line. I wanted to do this one because I struggled with the concept of the counters at first, versus the number line for me made total sense. Um, so for 5 minus -2, the answer is 7. So as you can see here for the counters, I started with 5 positive counters, and then because I was taking away, you had to have zeros basically, so a positive and a negative together, and I took away those 2 negatives out of the zeros, and that gave me 2 positives left over, so got 7. Same thing with the number line. I started at 5 because we are subtracting. The dude on the number line is going to be facing the left-hand side. And because we are taking a negative number, he's going to be walking backwards. So once again, we got 7. And then for 5 plus a -3, same basic thing. I started with the 5 positive counters, and then since I was taking away, I just added the negative. Well, since I'm adding negative numbers, sorry, I just added those negative counters right below the positive ones so that they cancel out, and I take those away because my answer is 2, so I'm left with 2 positive counters. And then for the number line, we once again start with 5. Because we're adding, he's going to be facing the right-hand side. And because the number that we're adding is a negative number, once again, he's going to go backwards. So 1, 2, 3, goes backwards, and he lands on 2. Excuse me. So then I did 32 to base 5 plus 44 base 5. And I wanted to show the addition and multiplication using base 5 blocks, basically, because I really actually like these ones. So I drew 3 longs and 2 ones for the 32 base 5, and then I drew 4 longs and 4 ones for the 44 base 5. Starting with the ones, you add them up and you end up having to regroup because we had more than 5 and we're only going to base 5, so I regrouped that into 1 long and I circled it in green, and then when I drew it over here in my final answer, I drew it in green. And same thing with the longs. I had more than 5 longs, so I had to regroup, and I drew those in red, and they became a flat. So the answer ends up being 1, 3, 1, base 5. For multiplication, once again, I really just liked these concepts. I found them very easy to understand. For multiplication, you draw it out in a graph. You've got 2 longs and 3 ones for 23 base 5. And for 1, 4 base 5, I have 1 long and 4 ones. So when you multiply a long by a long, you get a flat. And when you multiply a 1 by a long, you get a long. And so that's how we came up with these. Obviously, you can see my several circles and regroupings that I had to do. I had to regroup 2 sets of ones into longs and 2 sets of longs into flats. So my total answer, I've got the original 2 flats that were right here, and then I've got the 2 flats that I had to regroup, my 2 longs that I had to regroup, and then my other long and my 2 ones. So my answer ends up being 4, 3, 2, base 5. So that's those ones. Then I obviously had a couple more, but then I decided to go into my content knowledge, as seems to be my favorite thing. I really jumped around in with my numbers. As you can see, I started with 21, then I went to 50, 11, 12, 13, 17, 20, 25. Like I like to jump around based off of what is easiest for me. So I started with the ones that I knew right away that took minimal effort, but I felt were important ones to show that I knew the concepts on it. So I started with number 21, which was converting base 10 to base 5 and then vice versa. So I picked a random number of 361 base 10 to convert into base 5. So the most important part of this was drawing out my graph and showing that, to convert to base 5, we have 5 to the 0, 5 to the 1, 5 to the 2, 5 to the 3, and 5 to the 4. And then above that, I drew out what the actual multiplication for that was, which was 1, 5, 25, 125, and 625. So then I figured out how many times my number of 361 will go into these. So for 361, we can get two 125 blocks in there. So that's where the 2 came from. Then, so see, 125 times 2 is 250. So 361 minus 250 gave us 111. So we've got 111 left over. Well, I can get 425 blocks into 111. So that gave me 100. And then I was left over with 11. So 2 5 blocks and then 1 individual 1. So that's how I got the answer of 2421 base 5 is equal to 361 base 10. So then I did the same thing in reverse. I picked a random number of 3611 base 5 and converted it into base 10. So I did the exact same concept. I said, okay, so 3611, we have 3 in the 125 block, 6 in the 25 block, and 1 and 1. And I just realized I messed that up because you can't have 6. Okay, so I did this wrong. I am going to correct it before I submit my final answer, and we're going to move on to a different problem because I just realized you can't have a 6 when you're dealing with base 5. So I will change number 21. This is not the correct answer, and I will come back to that later. Okay, so moving on, I did a couple more. I knew doing number 33 was important, least common multiple and greatest common factor. For me, this was important mostly because I tend to get them backwards personally, so I wanted to make sure I had this one in here. So to solve it, we're dealing with the same numbers, 48 and 108 for both the greatest common factor and the least common multiple. You had to do the factoring tree to break it down and see what all the factors are. So as you can see, I made my trees for each of them. And then to come up with the least common multiple, you have to take all of the factors that are in both of them. So first I listed out all the factors of 48, which was 2, 2, 3, 2, 2. So that's all the factors of 48 right there. Then you have to add in, to come up with the least common multiple, any factors in 108 that were not already covered in this first portion that I did with 48. So we already got the 2s. We already have 2 2s right there. And then they had 3 3s. And that was the factors of 108. Well, I already had 1 3, so I just needed to add the 2 more 3s. So once I multiplied that all together, my least common multiple ends up being 432. For the greatest common factor, it's going to be something very similar. You have to find which numbers are in both. So in both of the factors, we have 2 2s, see, 2 2s, and 1 3. So that's how I came up with 12 is my greatest common factor. Moving on to some more fun stuff. Let's see. I did both the arithmetic sequence, find the nth term, and the geometric sequence. Once again, this was something that in the beginning of the semester I struggled with, so I felt it was important to make sure I covered that, and that way I have it. I did do very simple sequences, but it still is a mastery of the concept, I feel. So for the arithmetic sequence, the formula you have to use is a sub n is equal to a sub 1 plus n minus 1 times d. So a sub 1 is going to be your first number in your sequence. In this one, it's number 3. D is your difference, so that's going to be 2. As you can see, there's a difference of 2 each time in the sequence. So then you just plug it in. At first, I did plug it in with a basic number, trying to basically find the second answer. Even though I already knew it, I wanted to test my theory. So we had 3 was our first one. We're going to do n minus 1. So we're looking for the second number in the sequence. So n minus 1. So 2 minus 1 equals 1 times 2. So we ended up with 3 plus 2 equals 5. So it made sense. So that was obviously the sequence I was looking for. So for this one, it basically what the actual sequence is a sub n is equal to 3 plus n minus 1 times 2. This can be condensed down into 3 plus 2n minus 2, because I multiplied the 2 by the n and the negative 1. And then we can even reduce it down a little bit more by adding the 3 and the negative 2. So the answer is a sub n equals 2n plus 1. Geometric sequence, I basically did the same concepts. The formula for this one is a sub n is equal to a sub 1 times r to the n minus 1. Once again, a sub 1 is going to be the first number in our sequence, and r is the ratio, the difference between the numbers in the sequence. So each time we're multiplying by 2. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24, and so on. So that's how I came up with the ratio of 2. So for this one, the sequence is a sub n is equal to 3, our first number, times 2, our ratio, to the power of n minus 1. So to find, say, the fifth number, we're going to do 5 minus 1. So it's going to be 4. So 2 to the 4 times 3. And that would have given us 24. Magic! And then I did the staircase. I did the graph here to show that A or B and C is not equal to A or B and C. As you can see, two different pictures, not equals. And then I did the Mayan and Babylonian numbers because I really enjoy actually changing things from different bases to another base. I don't know why, it's just kind of my thing. So yeah, these are the ones I did. Hopefully everything is good. Like I said, I will go back and fix number 21 because I did this wrong. So you will see a corrected answer on my submitted paper. So yeah, thank you.